North Africa, a land spanning nearly 9 million square kilometers. A place where daytime temperatures can soar beyond 50 degrees Celsius. In some regions, not a single drop of rain falls for years. At first glance, the Sahara appears to be one of the most hostile environments for life on Earth. This is the largest hot desert on our planet.
Silent, relentless, and seemingly lifeless. For thousands of years, people looked upon the Sahara and believed that nothing could survive here. But today, we know that this belief was completely wrong, because the Sahara is not empty. In fact, quite the opposite is true. Beneath this endless ocean of sand lies one of the greatest hidden treasures in human history. A treasure so immense that it could sustain millions of people for centuries. Scientists call it the Nubian Sandstone Aquifer system, holding nearly 150,000 cubic kilometers of water.
It is one of the largest known fossil groundwater reserves on Earth. Its volume is so vast that it could submerge the entire country of Germany beneath hundreds of meters of water. But an even greater paradox lies beneath the sand. How can one of the driest places on Earth sit above an immense ocean of fresh water? And more importantly, how close is humanity to exhausting this ancient inheritance that has remained hidden underground for tens of thousands of years? Because this is not merely the story of water. It is a story of climate change, mega-engineering, geopolitics, and one of humanity's greatest struggles against nature itself. And perhaps the most unsettling truth of all is this. In this battle, time may not be on our side. Today, when you look at the Sahara, all you see is sand. But 10,000 years ago, this place was completely different. Much of what is now the Sahara was once covered by lakes, rivers, wetlands, and vast grasslands. Scientists call this period the African Humid Period. Beginning around 14,000 years ago, powerful monsoon rains reached deep into North Africa. The Sahara was far greener than the desert we know today. Satellite imagery and geological studies reveal hundreds of ancient river channels hidden beneath the sands. Some researchers even believe that enormous lakes, comparable in size to today's Great Lakes, once existed here. And this land was not merely green, it was alive. Archaeologists have discovered thousands of cave paintings depicting hippos, crocodiles, giraffes, antelopes, and even fish. In places where no signs of life exist today, people once fished, herded animals, and built communities along the shores of Great Lakes. But then, something changed. Subtle shifts in Earth's orbit began to weaken the monsoon systems over North Africa. Rainfall gradually declined. Rivers dried up. Lakes began to shrink. And a slow transformation, lasting thousands of years, had begun. The green Sahara
slowly became the vast desert we know today. But the water did not disappear completely. Instead, it seeped deep into the earth. Over millions of years, layers of sandstone trapped this water inside enormous underground reservoirs. And so, one of the greatest hidden water systems on Earth was born. But this water possessed one critical characteristic. For the most part, it could not be renewed. In other words, once it was used, it would not return. And humanity had no idea that this invisible treasure even existed.
Until the middle of the 20th century, no one truly understood how much water lay beneath the Sahara. Then came the search for oil. Deep drilling operations unexpectedly astonished engineers, because instead of oil, they began to encounter enormous quantities of fresh water. At first, it was assumed to be an ordinary groundwater system. But as the research progressed, a far greater reality emerged. Geologists had discovered a massive interconnected aquifer stretching beneath Libya, Egypt, Sudan, and Chad. In some areas, the water was found more than 2 kilometers below the surface.
But how did scientists determine the age of this water? The answer lay in isotope analysis. By examining radioactive isotopes within the water, researchers discovered that much of it had accumulated after the last ice age. Some samples were more than 20,000 years old. That is why scientists call it fossil water. Because, like fossil fuels, this resource is finite. Years later, NASA's GRACE satellites began studying this hidden system from space. The results were astonishing. Beneath North Africa truly lies an immense reserve of water. But an even more important question emerged. Could humanity bring this water to the surface? And if it could an entirely new civilization be built in the middle of the desert? Libya's answer was clear. Yes. And to achieve it, one of the greatest engineering projects in human history was set into motion. And if it could an entirely new civilization be built in the middle of the desert? Libya's answer was clear. Yes. And to achieve it, one of the greatest engineering projects in human history was set into motion. In the early 1980s, Libya decided to embark on an extraordinarily ambitious project. Its name was the Great Man-Made River. The objective was simple: to transport fossil water from deep beneath the Sahara to the country's major Mediterranean cities. But achieving this goal would prove to be incredibly difficult. The water sources lay hundreds, and in some cases thousands, of kilometers away from the population centers that depended on them. The engineer's solution was as bold as the challenge itself: build a colossal underground pipeline network across the desert. What eventually emerged was an infrastructure system stretching more than 4,000 kilometers.
A distance even greater than the journey from London to Moscow. Some of the concrete pipes used in the project measured 4 meters in diameter. Each individual pipe segment weighed between 75 and 80 tons. To manufacture these giant components, specialized factories were built in the middle of the desert. Millions of tons of concrete and steel were consumed simply to produce the pipelines. Many experts consider it the largest water transportation system ever built in modern history.
Libyan leader Muammar Gaddafi famously described it as the eighth wonder of the world. But distance was not the engineers' only enemy. They were also fighting the desert itself. Temperatures exceeding 50 degrees Celsius, violent sandstorms, remote regions that were incredibly difficult to access, and endless dunes that never stopped moving. Some construction crews spent weeks living in isolated camps, completely cut off from civilization. Even transporting water, fuel, and food to the workers became a massive logistical operation. Yet, despite every obstacle, the system finally began to operate.
For the first time in history, ancient water extracted from the depths of the Sahara began flowing toward the coastal cities. For millions of people, it was nothing short of an engineering miracle. But before long, a new problem emerged. Nature was preparing to strike back. Humanity had succeeded in drawing water from the depths of the desert. But as with every great engineering project, the real challenge was not building the system, it was keeping it alive. Because the Sahara is not a passive environment. The Sahara is a living system, and that system is constantly in motion. The first enemy was sand, but not ordinary sand. Saharan sand consists of microscopic mineral particles sculpted by the wind over millions of years. These tiny particles infiltrate filters, turbines, valves, and pumps, gradually wearing down the machinery. In some regions, sandstorms can exceed 100 kilometers per hour. These storms do more than reduce visibility to zero. They significantly shorten the lifespan of sensitive equipment. Engineers quickly realized that the desert itself was an invisible enemy. To keep the system functioning, thousands of kilometers of infrastructure had to be constantly monitored. Even a minor failure could threaten the water supply of millions of people. But the problem was not merely mechanical. Scientists began studying the long-term effects of heavy extraction on the aquifer itself. Because fossil water systems are fundamentally different from ordinary groundwater replenished by rainfall. Most of the extracted water can never be naturally replaced. In other words, every single liter removed is a liter taken from a reserve that accumulated tens of thousands of years ago. And this raised a critical question. Had humanity already begun consuming this invisible ocean? The water hidden beneath the Sahara is not only attracting the attention of scientists, because in the 21st century, water has become one of the world's most strategic resources. Oil can make nations wealthy, but water determines whether societies survive. The Nubian Sandstone Aquifer stretches beneath 4 nations: Libya, Egypt, Sudan, and Chad. Together, they share one of the largest transboundary groundwater systems on Earth. And therein lies the problem. This reservoir is, for the most part, non-renewable. If these nations exploit it without long-term planning, future generations may inherit far less than what exists today. That is why regional cooperation agreements have become increasingly important in recent years, because the future of this invisible ocean could shape the destiny of millions of people.
But the geopolitical risks go far beyond the issue of sharing water. During Libya's civil war in 2011, several facilities belonging to the great man-made river system were damaged. Some pumping stations were temporarily forced offline. The incident exposed a sobering reality. Modern cities depend entirely on fragile infrastructure. A pipeline, a pumping station, or even a single power outage. Any one of these can disrupt the daily lives of millions. And in truth, this lesson extends far beyond Libya. Modern civilization is built upon invisible systems. Power grids, internet cables, water pipelines, energy networks. Most of the time, we never even notice them until they stop working. And perhaps this is the Sahara's greatest lesson. Civilization is far more fragile than we would like to believe.
Twents. But what happens if one day this ancient reservoir is exhausted? This question is no longer merely theoretical. According to the United Nations, nearly half of the world's population lives in regions that experience water stress during certain times of the year. Climate change is only intensifying that pressure. Many countries surrounding the Sahara are growing rapidly. Cities are expanding. Agricultural demand is increasing, and more water is needed every year. Experts generally foresee three possible futures. Scenario 1. New technologies.
Desalination, the process of turning seawater into fresh water, may play a crucial role in North Africa's future. Today, countries such as Saudi Arabia and the Gulf states obtain much of their drinking water this way. But the process requires enormous amounts of energy and remains extremely expensive. Scenario 2. Smarter water use. Modern drip irrigation systems, intelligent agriculture, and water recycling technologies may become essential tools for survival. Scenario 3. The darkest possibility. Water shortages, mass migration, economic pressures, and regional instability. History has shown us that water can build civilizations, but it can also destroy them. Perhaps the greatest geopolitical conflicts of the future will not be fought over oil,
but over water. And perhaps that struggle has already begun.
Today, when you look across the horizon of the Sahara, all you see is sand. But beneath your feet lies an invisible world. A vast water inheritance that has remained hidden in silence for tens of thousands of years. Humanity discovered this inheritance. It brought it to the surface, and in the middle of the desert, it built a new life for millions of people. It was an extraordinary achievement, but it also revealed a profound paradox. The very system that sustains us is also finite. We did not conquer nature. We merely learned how to use its rules to our advantage for a little while.
But nature has a tendency to deliver the final verdict. And the Sahara teaches us something profoundly important. Our planet is not merely a collection of mountains, deserts, and oceans.
Earth is a vast machine made of interconnected, invisible systems. And we are not its owners. We are only its temporary operators. Because in the end, what will determine humanity's future is not technology itself, but how well we understand the limits imposed by nature. And perhaps the most important question still remains unanswered. When this invisible ocean is finally exhausted, will humanity find another solution? Or will the Sahara, as it did thousands of years ago,
silently reclaim everything it once gave?